You agree? Why? Because it has changed 10x from E to Y. That's what we have got. 10x is the change from over x meters of distance. Yes or no, beta? Correct?
Yes, sir.
Now, what will be the area of the trapezium? Area of the trapezium would be then half into sum of the parallel sides. One side is 65, other side is 65 minus 10x multiplied by the distance between them x. And how much I want this distance to be? I want this distance to be 20 units because the area of the triangle is 20. This gives me, this gives me, I can take 2 on the other side. So this will give me 130 minus 10x in the bracket into x. And I can take 2 on the other side, it will become 40. If I open it, it will become 130x minus 10x square is equal to 40. And now I can rewrite this 10x square minus 130x plus 40 is equal to 0. If I divide all of them by 10, I'm left with a quadratic equation. What quadratic equation am I left with? I'm left with a quadratic equation x square minus 13x plus 4 is equal to 0. I have to find the value of x. I will use the quadratic roots of the quadratic equation formula. Those of you who are able to get good enough, x will be equal to plus minus b, no, sorry, minus b, my mistake, minus b plus minus under root b square minus 4ac upon 2a. Here b is 13, a is 1, and c is 4. So x becomes equal to minus b is minus 13 plus 13, 13 plus minus under root. B square is 13 square, 169. 4 into a is 1, c is 4 minus 16 divided by 2a. A is 1, so divide by 2. This becomes 13 plus minus under root of 153 divided by 2. Can you quickly get what are the two values you are getting, guys, here? Can you quickly get what are the two values you're getting? 150 square root of 153, let me just 153 square root comes to 12.369. 12.369. So 13 plus minus 12.369. Let me make it 12.4. 12.4 by 2. If I add, it becomes 25. Half of 25 will be 12. So that gets ruled out. The possible only possibility is 13 minus 12.4, that is 0.6. Divide by 2, it's about 0.3. So x is by calculation also coming 0.3. So that means by calculation also this will be 2.3 meters from end B. So those of you who are more interested in getting 3 decimal places answer will have to use the quadratic equation concept. If you are not comfortable with it and you think you don't have that much luxury of time in the exams because you are a slow person who does slowly and you may not have time to toy with all these concepts, then you can dump it and you will have to say from the graph the BM is 0 at so and so location, whatever best you can read from your graph. Any questions, guys? So I have told you both the methods. Those of you who are mathematically sound, want to calculate, can calculate. If you are not in a position to calculate, obviously your answer will not be exactly accurate. There will be plotting errors that will be there. Okay. Guys, any questions on the last part of it where the BM would be nil between D and B? Or is it understood now? But guys, please respond quickly so that I can move on because I'm running short of time now actually. So if you have doubts, I'll be happy to address. Otherwise, you just can't be lying low.
Happy, sir.
Happy? Okay. So that takes care of these two questions, which have seen you through the process. In one, we multiplied with G. In the other one, we did not multiply by G. And the question has been through and through done now. Okay. Okay, I'll discard all this. And now we are done with it. This also I'll remove. This also I'll remove. And now we'll go to rationalized scale. Okay, guys. Which one is this? This I can remove. No, I don't need it. Okay, guys, this question is again, this was a 12-mark question. It was not a 25-mark question. It's very simple. Don't get worried. You already know. L can be anything. W can be anything. The only thing is the values are not given. So how is the beam? This is the diagram. I'll quickly take you through. If somebody has done, you can match. This is L. It is W per unit length. So what will be the total weight of it, beta? What will be the total weight of the beam? WL.
W12.
Yeah, the weight will be WL. Okay. Supported at the ends A and B. I'm sure in this case you know then RA will be WL by 2 and RB will be WL by 2. You remember that initially we had done the second question where it came equal? Yes or no? The second question that we had done. Yes or no, beta? RA and RB in this case will be equal. Why? Because if you see about the center line, the two sides, whether downward force or upward force, they are mirror image of each other. When they are mirror image of each other, then reactions will be equal, obviously, right? Okay, so now we can make a SF table. We can make it with 2 points, no problem, A and B, like the second question that we had done. Only thing is there, instead of with W, we had the weight. Instead of length, we have a value. We had a value. So we have A, B. Now here, SF units cannot be put. Why? Because he has not given me the units of the weight, nor has he given me the units of length. Okay. So unit of weight. I'll put here like this. Why should I leave it unattempted? Do I need to divide any one of them? Yes. A and B have point loads, so I need to divide them. What is to the left of A? 0. I carry forward 0. What is the change to the right of A? Plus WL by 2. So what is the shearing force? Plus WL by 2. I carry forward WL plus WL by 2 further. From A to B, what is the change? The weight of the beam comes into picture. So minus W, it makes it minus WL by 2. I carry forward minus WL by 2 from left of B to right of B, plus WL by 2 comes into picture, makes it 0. Any questions on SF calculations, guys, at the 2 points? Guys, if you have doubts, please speak up so that I can explain and move on. Otherwise, we'll lag behind. I want to finish in time, but does not mean that I want to compromise on quality. No, that's not the intent. If you have doubts, please shoot them out. No issues. Everybody happy with the SF values? Yes or no?
सर ये बी वाले कॉलम में
Yeah,
टॉप
tell
में
me.
सर माइनस WL होना चाहिए सर वेट ऑफ द बीम इज
Minus
WL.
WL. Then only, okay, I missed out L beta. That's why it will become minus WL by 2. Weight of the beam is WL. You're right. You're correct. Okay. Anything else, guys? That was my miss. Okay. Now we draw the SF diagram. A, B. We take any scale WL by 2. Same distance we mark on the other side, that becomes minus WL by 2. And then at A, it goes from 0 to plus WL by 2. At B, it goes from minus WL by 2 to 0. And then you join them with a straight line because it is changing at a uniform rate of W units per unit length. It will cross the x-axis at center or C, whatever you want to call it. This is the SF diagram, guys, and C has been written after the diagram has been drawn. Is the SF diagram okay? This is minus WL by 2. Is the SF diagram done, guys, or any questions?
Done, sir.
Done. Okay. Then what will be the length AC? It will be L by 2. What will be this length? L by 2. Now for BM, we'll have to take 3 points by areas under SF diagram. You can write that. We have already done in 2 questions now in complete details. A, C, B, BM units based on force, weight, and length combination. Okay. So at A, it is 0. I carry forward 0. Then plus the area of the triangle plus half. Base is L by 2. Height is WL by 2. Leaves you with W plus WL square by 8. You carry plus WL square by 8 here. Then minus half L by 2 into WL by 2 becoming 0. Now we come to the BM diagram. It's only plus, so there is no need of having anything down below. A, midway C, same distance B. You can take any scale here. BM is here. So this is plus WL square by 8, guys. It is 0 at A, WL square by 8 at C, and 0 at B. We now just need to shape the SF diagram. Since we are integrating areas under a slanting line, it will be curve. The first area is from base to vertex. It will be like this. And mirror image of this would be on the other side. Exactly the same will be on the other side. This will be the BM diagram. This is BM, this is SF. Any questions, guys? There is no sharp point here. It's just like this, right? Is this exam question understood, guys? In case they get repeated or something.
Yes, sir.
Okay. Anybody who wants to take screenshot, please take it. I'll move on to the next one then. Okay, so we have done these 3 questions. One we had done yesterday. This is what we just discussed. Now I'll come to the concept of cantilever, guys. I'll try to finish cantilever by 11 o'clock so that we are in time to move on to box-shaped vessel gradually, okay? But again, as I said, don't compromise on the understanding because whatever is done should be frozen once for all. Okay. Guys, let me first explain to you the concept of cantilever. Okay. See, until now, the beams that we took, they were supported minimum at how many points, beta? Minimum of how many points were they supported? The beams that we have solved until now, what was the minimum number of supports? 2 points, minimum 2. Yeah. Now you must have seen the plumber when they want to thread the pipe. What do? To support their vice, what they do? They put a small angle or eye girder into a wall. Now that girder is a beam, that angle is a beam, that C channel is a beam. And when it is put into the wall, it is supported only at one point. How about the balcony of your house? It's supported only at one end. The other end is hanging free, unless you put pillars under it. Of course, that's an exception. Nobody does it unless it's about to fall down, right? So if a beam is supported only at one point, then it is called a cantilever. Understood, guys? If a beam is supported at only one point, needless to say, if it is supported at one point, it cannot be balanced unless it is rigidly fixed into that support. Yes or no, beta? Am I right? With single point, the beam can be balanced only if it is rigidly supported. Am I right? Correct, beta? So a beam which is supported at one point is called as a cantilever. So cantilever is clear to you? Now, so what are we saying? That if this is the wall and I have a beam like this, light beam, this is a cantilever. If I have the wall like this is the cantilever. If I have wall like this, and instead of light beam, I take a beam of uniform cross section, this is a cantilever. This is a cantilever. These are the beams of uniform cross section. The above ones are light beams. Okay. Now, so these are basically light cantilever with light beam cantilever, and uniform cross section beam cantilever. Now in this, guys, the ends which are fixed are called as fixed ends. The ends that are fixed, that means this end, this end, this end, this end, they are called as fixed ends. Okay, whichever they are, right? Fixed end. Okay. The end which is not supported, is called as a free end. So this one, this one, this one, and this one, they are called as free end of the cantilever. Okay. Now you will say, why have I drawn the two sides of the light beam and the one? This is called left end supported. Both of them supported. In these two, the left end is supported. In this case, the right end is supported. Have you understood what is the concept and what is the concept of the cantilever, beta? Guys, any questions on what is a cantilever, what is its free end, what is its fixed end, what is right supported, what is left supported? Clear?
Yes.
Fantastic. I'm clearing this slide, huh? Then don't, because this will all disappear. I'm clearing this slide to continue. Okay. Now, when you do for cantilever, your working does not change. In fact, the first step becomes easier. Why? Because when you use a cantilever, there is only single support. And that support, so this light beam can have a weight here, can have a weight here, they can have a uniform load anywhere you want to put. You can load it the way you want, the way you are loading the beam. But whatever are the total forces which are acting downwards, the reaction has to be here. Yes or no, beta? Nowhere else. Because it is not shared by anybody else, any other point. Yes or no? Entire reaction will be at the support. There is no sharing. Correct, beta? Have you understood what I'm saying, guys? The
Yes,
entire
sir.
reaction will be at the support. Okay. Now, guys, so one step is less. You don't have to calculate the reaction. Shearing force concept is exactly the same as you have done with the beam. No change. No change at all. Okay. The only change is about the BM. What is the change about the BM? Change about the BM is that in a cantilever, since it's fixed at the one end or at one point, where it is fixed, its fixed end has the maximum BM and the free end BM is zero. The BM at the free end is zero and the BM at the fixed end is maximum. So the change is, so with respect to the beam that you know, the first thing is no need to split reaction. Entire reaction is at support. Okay, that makes it easier. Second, SF, no change with respect to beam. Third, BM for a cantilever, free end has zero BM, fixed end has maximum BM. Is that clear, beta? Have you understood what I'm saying? We'll see it through the questions. So, if you every time go from left to right, you may end up making BM zero at the support, if it's a left end supported, and you may show maximum BM at free end, which is not going to be the case. Okay. I'll tell you how can you hedge that risk a little bit. Okay. So please remember that BM of a cantilever is zero at the free end and maximum at the fixed end. Is that clear, beta, what I'm trying to say here?
Yes, sir. What is the second point, sir? SF, no change, sir.
SF is no calculation of SF is same as you are doing with the beam. No change.
Okay, okay.
Okay. If you're going from left to right, upward will be positive, downward will be negative, and you keep taking stock of the forces, right? Okay.
Yes, sir. Copy,
For
sir.
BM, you'll have to be careful that if your BM free end is to the right, then it will be zero at the right end, not at the free end, not at the fixed end. It will be zero at the free end. Okay. Now, let me see this question, or let me just go to our questions. Why waste time here? Let's not worry about it. Okay, let's take this one. It's MMD 2018. A cantilever. Now, guys, you have to read the question carefully in the first place and see. If the question says left hand supported, then you have to make left hand supported. If the question says right hand supported, then you have to make right hand supported. Okay. If the question does not say anything, then you can make whichever way you feel comfortable. But the diagram orientation for left hand supported is going to be different from the one. If one is positive, in other it becomes negative. So don't get confused if you're walking in the exam hall to go to the loo and you see somebody else's diagram and you see that yours is above the x-axis, his is below the x-axis. Maybe he has changed the ends. Okay. So don't get confused. Sometimes, these things unnecessarily set panic in the exams. Okay. So let me just, I'll do this question both with left hand supported and right hand supported, and you'll be able to appreciate the change. Okay. Now, again, first let me do the left hand supported. So let me first do with a left hand supported one. This is the last of the topic pertaining to beams, guys. So a cantilever carries a concentrated load. That means it's a light beam cantilever, beta. So this is the wall. I'm making it left hand supported. And here is my beam. It's 6 meters long. it carries 45 kilonewton at its free end and uniformly distributed load of 20 kilonewton per meter over its entire length. Okay. So that means there is a UDL here. Like we are doing exactly what we were doing in beam beta. I'm not changing anything. So this is the cantilever AB. This is 120 kilonewton at the rate of 20 kilonewton per meter. And then you have a concentrated weight here, which is 45 kilonewton. Guys, is the diagram clear to everybody or there is any confusion about the diagram? Tell me first. Is the diagram clear?
Yes, sir.
Okay.
Yes,
How
sir.
much will be the total reaction beta? First tell me what will be the total reaction. It will be 120 plus 45, 165. So reaction will be at A, it will be 165 and it will act in the upward direction. Reaction acts in the upward direction. Am I right, guys? Correct, beta? Is that right? Any doubts? Okay. Now for SF, if it was a beam, do you need to take any more points than A and B or A and B are good enough, beta? For SF table? If it was a beam, how many points would you have taken? Tell me.
2, sir. AB.
2. So 2 are good enough. So I'll take 2, right? A and B. Any one of them needs to be divided into 2 or none of them or both of them or one of them? Tell me.
So B as B and A.
Both, because A also has reaction which is concentrated. You're right. Correct, beta? So this is the SF. Units will be kilonewton this time, beta. To the left of A, it is 0. I carry forward 0. To the right of A, plus 165 comes into picture. So the reaction is 165. This is what you're doing with the beam. Then I carry forward 165. From A to B, one is minus 120 newtons comes into picture. That's all that comes into picture. And this leaves you with plus 45. You carry forward plus 45. You have minus 45 and becomes 0. Guys, am I okay with my values or you want to challenge any one of them? The shearing force table is exactly the way you are doing with the beam, no change. Yes or no? Link it to beam so that you don't unnecessarily make it a new topic altogether. Clear, beta? बोलो भाई फटाफट बोलो. SF values are okay?
So this 120, how we got minus 120? Because the load
Weight
will
of
be
the
that.
weight UDL beta. UDL is there, no? This blue thing on the diagram.
Okay.
From
But
A
that
to B,
will
this will that
act
UDL of
as
120 kilonewton, no?
0.6 and
Sorry? What I am saying, what for shearing force, what do you look at? What is the change from A to B? So from right of A to left of B, what is the change?
yes, sir, only UDL weight, sir.
So that is what we have brought, na bete? Correct?
Okay.
And then from left of B to right of B, 45 concentrated load comes and becomes 0. Yes or no? Am I right?
Yes, sir.
Okay. Now we make the SF diagram. We have only 2 points, A and B. Our values are plus 165 and plus 45. So, okay, let's say here is plus 165 to a suitable scale. 190, okay, 45. Let's say here is plus 45, okay, the scale. So what happens for shearing force? First, you will go from A to, at A, you will go from 0 to plus 165. So this will be the shearing force at A. Then from 165, it comes to plus 45, and then it will become 0 at B. Now, what happens in this case? You see, look at the beam diagram. Is the change from A to B at a uniform rate, or is it at a varying rate? Tell me. Look at the diagram and tell me whether the change is at a uniform rate or varying rate. Bolo bhai, fatafat. Is the force from A to B changing at a uniform rate or varying rate?
Varying rate.
Uniform rate.
Okay, where is it varying? Beta, tell me. Where is the variation? Please identify.
At B itself.
From A to B, I am saying at B is not the question. You're going to join from right of A to left of B. Yes or no? These are the free ends, correct? So from right of A to left of B, is the change varying or is the change uniform?
Uniform.
So that means you'll put your scale and join with a straight line. This becomes your SF diagram. Okay, guys? Okay. Now, looking at the SF diagram, do you think there is a need to have an additional point for BM table? Yes or no? Guys, is there a need to have an additional point?
No, not crossing that.
No, sir.
Not required.
Okay,
Not
so
required.
now is where the care is required, right? What happened to it? Okay, it started taking my voice. Okay, no, how do I disable? Let me end the show and come back to it. Okay. Okay. So we don't have to take any extra point. We can take this, but now there is a here you need to exercise. PM will be kilonewton meter. Now, guys, you'll have to be very careful. Now, A, right, fixed end to avoid errors. B, free end. And now I will go from free end to fixed end. Please pay attention to what I'm saying now. PM is the issue with cantilevers. Now, in my case, if I have to go from free end where it is 0 to fixed end, will I be going left to right or right to left, guys? Is it right to left or left to right?
Right to left, sir. 0 to.
You're going in this diagram, you're going right to left. When you go from right to left, the sign convention gets reversed. That means whatever SF area is above the x-axis, the BM will be negative because SF is positive, BM will be negative. Correct, beta? We discussed this in the 2.55 meter question also yesterday. Yes or no? Where I was talking about the triangle, which was above the x-axis. You remember yesterday's discussion also? Now, from free end to fixed end, I'm going from left to right. Or do one thing, you change the format of this table. Let me make the BM table here. In BM table, you always put the free end first. Change the order. That will be simpler to avoid mistakes. BM will be kilonewton meter. First put the free end and then put the fixed end. I look at my diagram. Free end is B, fixed end is A. What is the bending moment at B? What is the area to the right of B? It is 0. I am coming from right to left. Firstly, what is the area to the right of A now? Area to the right of A, I carry forward this 0. And then the area of this trapezium, which is first, let me get the trapezium, I'll come to the sign later. Sum of the two sides, 165 plus 45 into the length of the beam, 6 meters. This becomes 70, 210. 210 into 3. How much it becomes? 630. Am I right, guys? Does it become 630? Into 3. 210 into 3 will be 630. Yeah. Correct. Now I have to put the sign, guys. In my area, I have gone from right to left. When I was going from left to right, positive SF area was giving me positive BM. But now I'm going the other way. If I'm going the other way, the positive SF area will give me negative BM. So this BM will be negative. Please pay attention to this. Pay attention to this. This will give you negative BM. And now, once I can put the sign to it, I'll be able to draw the BM diagram. The catch lies in the BM diagram where you'll have to be careful. My BM is negative, so I can have the x-axis here. It's A, it's B. My maximum BM is here, minus 630. My BM at A is 0. I have to join them. It's a trapezium from smaller side to the bigger side. So basically, it will be like a triangle from vertex to base. This will be the BM for this particular question. Let me change it to green color, the BM diagram, so that it's clear, different from the axis. This is the BM diagram, guys. Please review it, and if you have any clarifications to seek on this particular case, let me know. For BM of a cantilever, make your table always from free end to fixed end. Free end to fixed end. Because free end BM in a cantilever is always 0. Free end BM in a cantilever is always 0. Guys, is that clear? Please let me know so that I know whether you have understood. Or if you have any doubts, speak it out. Even if you have understood, please confirm it so that we can move on.
Sir, could you repeat your last statement? Free end of the cantilever
I have already said it a couple of times, beta, that BM of a cantilever is 0 at the free end and maximum at the fixed end, at the supported end, fixed end or the supported end, whatever you want to call it. Fixed end and supported end are the same, beta. Okay. Fixed end and supported end mean the same. So BM is minimum or 0 at the free end and maximum at the fixed end or the supported end, as you can see in this diagram also. So what have I done? I changed the order of my table. How did I make the table? I put B first, then A. I made my, so what I do is, I always suggest my boys also like this. When you make the BM table, put here from free end to fixed end. It reminds you also, and it conveys to the examiner also. And also by areas under SF diagram. Put these two remarks here in the bracket itself. You'll never make a mistake. You will never make a mistake if you do it like this. Sometimes we don't want to put these small points, recall them, don't want to put them down, and therefore we miss out and we make blunders. Is that clear, beta? Okay. If no questions, good. I have saved this one.
What
Sorry?
difference it would have made if we keep A before and B after?
I already in the table.
Yeah, that is correct, sir.
I'm just suggesting you which can make your calculations easier, because then the moment you have the free end first, automatically then your area will be 0. Otherwise, you'll have to start from here. As long as you don't make a mistake, it's okay. It doesn't make any difference. Okay. Okay. As
Okay.
long as you don't make a mistake, then it's okay. I'm just suggesting, when some certain suggestions are given, they are given with the intent of avoiding mistakes or minimizing the risk of mistakes, right, beta? Okay. If you still want to go on the mountain top and jump from there, it's your choice. Okay. Let me do the same question with the right end supported. See, if I have to cut short, I can say, okay, done, let's go to the next one. But I don't want to just rush through. If I have a right end supported, and then don't ask me, then should I always make this? I don't want to answer such questions. It's your choice. Okay. This is A, B. Now B is the fixed end. I've changed the fixed end to B. It has a UDL of 120 kilonewton and it has a fixed 45 kilonewton. RB will be acting upwards, will be equal to 165 kilonewton. SF, now I can continue working from A to B, no problem. Both need to be divided. We have already discussed 0 minus 45. Sorry, my mistake. Minus 45, minus 45, minus 45, minus 120, minus 165, minus 165, plus 165, 0. And then the SF diagram comes like this. It comes to minus 165 and 0 minus, okay. So here is A, here is B. This is SF diagram. Minus 165. At A, it is 0. 0 to minus 45. So at A, it goes from 0 to minus 45. So it goes from 0 to minus 45. Then it goes to plus 165 and becomes 0. You compare this. This was above the x-axis. This has gone below the x-axis. Understood, guys? By changing the supported end. Yes or no? The left hand supported diagram is there on top. Can you compare the two SF diagrams? They are same in shape. They are same in area. Only thing is one is above the x-axis, other is below the x-axis. Am I right, Vite? Yes or no? Can you compare these two axes by changing the fixed end? That's what I was saying. Don't get confused if people support different ends, right? Okay. Now I make the BM table. Again, A1 from free to fixed end to by areas under SF diagram. Now, when I'm going from free to fixed end in the SF diagram for this particular case, am I going from left to right or right to left, guys? Am I going from left? Free end is A, fixed end is
Left
B.
to right.
Left to right. So negative will remain negative, positive will remain positive. So it is 0. I carry forward 0. This is minus 165 plus half into, sorry, minus, my mistake, minus 45 plus 165 into 6 or whatever it is. This will give you whatever BM we got there also. We got a BM of, how much did we get? Plus is minus 630. Yes or no, beta? Correct? Okay. Now, when you make the BM diagram in this case, I always recommend, again, these are recommendations. Draw your y-axis at the fixed end. Draw your y-axis at the fixed end. My fixed end is B. I will draw the BM axis here now. Okay. Even this axis you could have drawn there, no problem. That's up to you. But I'll draw the thing here. Now, if I draw it here and it's minus 165. So now this is A and here is, sorry, here is A and this is B. My mistake. At A, the bending moment is 0. At B, it is minus 630. I'm integrating from lower, smaller side to bigger side. So it will be a curve like this. So this will be the BM diagram if the same diagram was made left hand supported. Right hand supported, sorry. This case that we have solved, this is right hand supported, and this in the inset is the left hand supported. You can compare the two. Both are correct because he has not said which side is supported. Both are correct because he has not said which side is supported. You can compare the two, and between the two, if you have any confusion or you want any more clarification on this, let me know, guys. See, there have been debates on cantilever. Initially, people used to say cantilever is not in the syllabus. Then people used to make hue and cry in the exam. Sometimes the replacement question used to come. Then slowly the replacement stopped coming. And then in one of the recent papers, we'll go to that question next. The guys are just going overboard. They have protruded a part of the fixed end also beyond the wall. I don't know how far they want to go messing up these questions, because for our ship's purpose, we don't need to know that. But nevertheless, if it's in the question, we will just complete the process, beta. So guys, is this with end supported clear, beta? One single point end supported, left and right hand. Any questions on this? You can take the screenshots and at your piece convenience, you can look at them and get back to me if you have any doubts. I take the last of the questions on beam. This one, guys. No, this is the same one. I take this one. You see, what has it done? A uniform log AB, 10 meter long, weighs 100 kilonewton. It is supported at a point 2 meters from end A, single point support. But where is the support? It's not at the ends. It's 2 meter inside of end A. It also carries a point load of 30 kilonewton at end B. Draw the SF and BM diagram of the beam, stating their values at the interval of 2 meters, MMD 21. Now, this sort of question is actually, genuinely, if you ask me, is just to bother people and nothing else. Somebody is trying to just pick up from some engineering knowledge book and trying to bother you for no reason. Honestly, if you ask me. Okay, the log is the beam here, guys. It's a single point support, so it's a cantilever. But what happens? It is supported like this. If this is the wall, if this is the fixed wall or something where it is supported, because if it is single point, then it has to be rigidly fixed. It cannot be just balanced on it. It cannot remain balanced. And again, I am keeping with the left side lesser one. So let's do it only one way. Is it a log of wood? Yeah, it is a log of wood. So I've taken it like this. This is the beam. It's 10 meters long, so it's 2 meters on this side, and obviously 8 meters on this side. It's AB, so A is here, B is there. Okay, and it also carries a point load of 30 kilonewton at its free descent. Guys, can you please read the question and tell me if you're convinced with the diagram, or is the diagram trying to say something else? Let me know. This is the wall. Okay. Does the diagram match with the question? Guys, please confirm. Do you agree with the diagram? Is it as per the question, yes or no?
Yes, sir.
Yes, sir.
Okay. So now, what is the weight of the beam on this side? So what is the total reaction? Let us say this is A, let's call this point as C, not the center, it is C. Okay. So what is RC? How much is RC equal to, guys? And acting upwards, who will tell? Please tell me how much is RC?
One 30.
130 130
130.
kilonewtons. Okay, very good. RC. So we'll do only one way, this way. We'll not make the support other side and unnecessarily confuse anymore. So be careful about the signs. Okay. Let's make the SF table. I'm sure you'll agree with our understanding of the things. This is 100 kilonewton at the rate of 10 kilonewton per meter uniform. Okay. We can make it for 3 points. I don't know if it has to be divided or not. Okay. Okay. This is SF in kilonewton. We have A, we have C, and we have B as per our diagram. Guys, any of them have to be divided into two? Tell me, any of these cells need to be divided into?
C.
Any? Sorry?
C. CB.
C and B, okay. Continue like beam. To the left of A, it's 0, shearing force is 0. To the left of C, it is
-20.
-2 into 10, that is -20.
Yes, sir.
To the right of C, it is -20
Plus 130.
plus 130 plus
110.
110. I carry forward plus 110. Okay. And when I carry forward this 110, to the left of B, I'll have 8 meters of beam weight, 80. It will leave me with plus 30. I carry forward plus 30. I have minus 30 becoming 0. Yes or no, beta? Am I right? Am I right, guys? I'm sure this one is not causing concern to you.
Yes, sir.
This is now my shearing force diagram. It's plus, 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 or no, there is a minus 20 also. Okay. I'll just put the values, never mind about the scale. We'll use the values to just quickly finish it off. Okay. Here is A, here is C, and here is B. See, what have I done? I've taken the axis in line with the support. I've taken the axis in the line with the support. This represents SF now. At A, it is 0. At C, it is minus 20. And at B, first, then it goes to plus 110. Then at B, it becomes plus 30. And then it becomes 0. And it's changing at a uniform rate because that is the weight of the beam. So A to C will be like this, a straight line triangle. Then it will be like this. Then it will go to plus 30 at a straight line and become 0. This becomes the SF diagram. Does everybody agree? It is a simple concept of beam, whatever we had learned. There is no change we made up in this until now. Yes or no, beta? I made put the axis in line with the wall, in line with the support. Is that clear to everybody? Yes or no?
Yes, sir.
Okay. Okay. Now is the catch in this question, and why they brought it, I don't know. Now we make the BM table. We make the BM table. We don't need any extra point, but there are two free ends, A and B, guys. So from free to fixed end by areas under SF diagram, right? I'm making this table big for everybody to clearly see and understand. Not that it needs to be done that way. Bm will be kilonewton meter in this case. I have point A, which is a free end. I have point C, which is a fixed end, and I have point B. If I were to do it, you want to do it differently, you can do it. Okay. C is fixed. A is free end. Bm here will be 0. Bm here will be 0. Okay. Now this will be to the left of C. I have divided the Bm for the first time into 2. Okay. Because this will be for side A. From side A, if I come to C, the Bm, I carry forward this 0 minus, why? Because I'm going from left to right, minus half into base is 2 meters, height is 20, becomes minus 20. Yes or no, beta? Am I right, guys? Do you agree it becomes minus 20?
Yes, sir.
Now I'm coming from this side, beta. This 0 I have brought here. Now let me change the color of the marker in the table itself. Or you want to make 2 tables, that's up to you how you want to do. This is 0, I carry over this 0. Guys, now from B to C, am I going from right to left or left to right? Now I'm coming like this. B to C, am I going from left to right or right to left? Look at the table diagram.
Right to left.
So if SF is positive, BM will be negative. Am I right, guys? Am I right?
Yes, sir.
Yes or no?
Yes.
So it will be minus half into sum of the parallel sides 110 and 13, 30 into 8. So this becomes 140, 70 minus 560 if I'm not mistaken. Can you check it, Vita? Yes or no? Yes or no?
Yes, sir. 560.
Okay. Now, if you want, if you are not happy with this table, if you think there is a confusion, you can split. Now, these are the options I'm giving you so that you have clarity. If you want, you can split your table into 2 parts. You can do the BM like this, guys. Let me do it here slow in this part. BM table A, nee, first A to C, second B to C. So you make a 2-point table here, A and C, and you make a 2-point table here, B and C. Is that clear, beta? Am I clear? Or B and C, whatever you want to write. Understood? So if you're not happy this way, if it is causing confusion, you can split them into 2 like this. Understood? Okay. Now we'll make the BM diagram. We again have the axis in line. We have minus, everything is minus, so we have it here. We have this as A, this end as C, this end as B, and then we have minus 20 here. And by the same scale, you can go to minus 560 wherever it goes, right? Now, if I go from A to C, if I go from A to C, I'm going from vertex to base. So it will be, the bending moment diagram would be like this from A to C. If I go from B to C, I'm going from smaller side of the trapezium to the bigger side. and this will be more like this. This will be the bending moment diagram out here. For this side, if you want, you can join them here. If you don't want to join, you can leave them separately, no problem. Because the beam, because of the rigid support, is now acting as two independent cantilevers. As far as BM is concerned, each side is tending to bend the beam at the fixed end, and the fixed end is supporting it. Okay. Have you understood the BM diagram for this question, beta? You want, you can leave this yellow also. That's not an issue. You don't want to make that blue. That has no relevance actually. It's merely a matter of choice. Doesn't make a difference either way. If you want to leave, you can leave it orange only. This like this. And you'll have two BM diagrams, one from B to C, another from A to C. And this is an MMD April 2021. I don't know whether there was a replacement or not. I have no idea. It's not documented anywhere. But this is how this question can be solved. Is this clear, beta? Okay. You can take the screenshot, refer to it, and get back to me with doubts. I have completed all the questions about beam where I thought in my wisdom you could have problems in solving. So all those have been taken and addressed here. Okay, guys, I give you 5 minutes break. I give you 5 minutes break. At 11:25, we'll start with this question, which is on display. It's again a beam. This is the last beam question we are going to do, and then we will move to box-shaped vessels. Okay. So take a 5 minutes break. 11:25, we continue further. Okay, can we start, guys, if you're back? Class, can we get back, please? Guys, can you confirm if you're back to the class?
Yes, sir. Yes.
Okay, let's start with this question then. A beam of uniform cross section, 40-meter long, weighing 320 tons, is completely resting on a plain horizontal surface. We have done with a beam resting on a horizontal surface in the morning, guys. So here is this beam. It's 40 meters long. The length of the beam is 40 meters. It's of uniform cross section. Its weight is 320 tons. So at the rate of 8 tons per meter. This beam is completely resting on a plane surface. We already understood what does it mean. That means the beam is fully supported on the plane surface. And the beam carries a UDL of 200 tons each over 10 meters of its end length, 10 meters of length from each end. And so 10 meters of length from each end it carries. So this will be midpoint, this will be 10 meters. Then it carries a UDL of 200 tons here. Obviously, since it's uniformly distributed, it shall be at 20 tons per meter. There is another UDL, similar UDL at the other end also, 200 tons at the rate of 20 tons per meter. And over the mid 20 meters of length which is left, it carries 800 tons of UDL. $800 tons at the rate of 40 tons per meter. Why? Because it is over 20 meters of length. Guys, does everybody agree with this diagram? Please let me know. First, have your confirmation about the correctness of the diagram with respect to the question.
Yes, sir.
Okay. We have done a similar question in the morning. The reaction will be uniformly acting along the entire length. The total reaction will be the total downward weight, which is 320 tons of the beam plus 800 plus 200 plus 200. That means 1520 tons will be the reaction. Am I right, guys? And it shall be uniformly acting along the entire length of 40 meters. So at the rate of 4 3 is the 12, 38 tons per meter. Am I right, guys? Reaction will be 1520 tons at the rate of 38 tons per meter. Have I done the reaction part correct? Please check on the calculators.
Yes, sir.
Anybody has any questions on the diagram until now? Though we have done a similar question in the morning. I started with that question and I'm ending the beam with the similar question. It was intentionally done in the morning upfront so that when we come here, you don't have those questions to ask. But if still anybody has a question, please let me know. We know how to make the SF in this case. How many points you think we should be taking for the SF table between this minimum points? 4. Minimum 1, 2, 3, 4. Minimum, absolutely right. Minimum 4 points, and which are, let me just, as I write, you tell me where to stop. One is obviously and A. Then let me know where to stop as I'm moving.
Sir, B, here.
Okay, B. Let me know where you want me to support. Stop. Here.
C.
C and D. Correct, guys?
Yes, sir.
Okay. Now, I have taken this question with a certain purpose, so I'll just take another extra point. I told you if I take one more extra point, there is no harm done. So let me take this as C, this as D, and this as E. I'm taking intentionally extra point, but you are absolutely right. It can be done with 4 points. It's not required. Okay. Or we'll do with 4 points. We'll skip C for the time being. Never mind. I've just named point C. Okay. Okay. Let us make the SF table with 4 points. We'll skip C since C is actually not required. You're absolutely right. SF will be in tons. A, B. I'm skipping C, then D and E. And what am I getting then? At A, SF is 0. Guys, what will be SF at B? Would you like to calculate ahead of me? Plus 100, am I right, guys? At B, the SF is plus 100, am I right? Please calculate and see.
Yes, sir, right.
Anybody who's having a question, any question in the mind? By now, you should be on top of how to get the SF of a beam. I carry forward this plus 100, and then I look at the diagram. What are the changes taking place from B to D? There was no need to divide any one of them because there are no point forces involved in this question. So that's why no cell has been divided. I'm sure you understand that. One is for 800 tons of downward weight comes into picture. Other is 20 meters weight of the beam. Third thing is the 20 meters of reaction. How much does it come to, guys? Does it come minus 100? Can you
Minus
please
100,
check?
sir.
Okay.
Minus 100.
Okay. Then we carry forward this minus 100. From D to E, the changes involve 200 tons of downward weight, 10 meters of beam weight, and 10 meters of reaction.
0.
And this will become 0. And now when we basis these things, if we make the SF diagram, if I had taken C, then still I would have got the values. That's not an issue. I get the SF diagram like this. I have point A, point B. I intentionally skipped C, and then I have point E. Sorry, this is D. This is D. I have the values ranging from plus 100 to minus 100. Same value up and down. Now with look at the diagram again, beta. Can you confirm if all changes from A to B are at a uniform rate? From A to B, there were 3 forces: weight of the beam, 200 UDL, and reaction. All are changing at a uniform rate from A to B. So the resultant from A to B will change at a uniform rate. Likewise, B to D, everything is changing at a uniform rate. So the change will be uniform. And then hence all will be joined by straight lines. So that means I start with this here. At B, I get plus 100. I join with a straight line. At D, I get minus 100. I join with a straight line. At C, I have 0. I join with a straight line. Do you agree this will be the shear force diagram, guys? Do you agree with the shearing force diagram, which you should now, until now, be absolutely clear about because we have dealt with the beam in so many questions, beta? Anybody who has a question about it, because I'll be closing this presentation because now from this, I don't think I need to discuss BM. from shearing force, you can get the BM. All of you can get the BM, yes or no? Anybody having doubts?
The last point in the diagram will be E, right? Not C.
C was here, no? We have C is here, no, beta? Last point in my, so okay, you are saying here. Okay, sorry, my mistake.
D, yes,
Okay.
sir.
Okay, my mistake. That was my mistake. Okay, that was my mistake. Okay, fine. E. Now, I'm sure you'll agree that it is cutting at the midpoint C now. Yes or no? Why? Because it is plus 100 this side, minus 100 this side, so it will cut in between. Yes or no? Correct, beta? So SF at C becomes 0. Do you all agree that SF at A is 0, at B is plus 100, at C is 0, D minus 100, at E 0? Do you all agree? Yes or no?
Yes, sir.
And from this, can you all get the BM and BM curve? I'm sure you'll know the BM diagram shape will be like this. A, B, C, D, and E. I don't care for the values. The maxima will come at C. From A to B, it will be from vertex to, I can predict the shape. It will be vertex to base, and then it is base to vertex. So it will keep rising, and then it will become like this. And so this will be the shape of the BM diagram, guys. Values can be calculated by the areas. They are both sides are symmetrical. Okay, so there is no difference between the two. Whatever is this shape on the left, the other side is exactly the same. You can turn the paper and give it shape if you have a problem in working with the left to right. Now this we know this beam you have solved. Had I given you this beam problem, can you all solve this question? Yes or no? Correct, Vita? Okay. That's all I wanted to hear from you. Now we go to the box shape vessel. Yes.
Excuse me, sir.
Yes.
Sir, there is a small doubt in last question. Sir, एक बार C का SF calculate करेंगे please. C पे.
आप calculate करो. You tell me. You guide me.
मैं calculate किया था सर तो गलत आ रहा है that says.
कितना आ रहा है बताओ ना कैसे गलत आ रहा है बताओ. C के लेफ्ट में क्या क्या फोर्सेस है बेटा? टेल मी.
C के लेफ्ट में सर
from B to C, what are the changes? B you already know, it's plus 100.
Yes sir.
From B, what are the changes?
B to C से minus 80 हो गया.
Okay.
Then minus 200 हो गया. 400.
Why minus 200? Minus 400 होगा ना.
Minus 400 हो गया सर.
And what else?
Minus 380 हो गया सर.
Minus 380 क्यों होगा? Plus नहीं होगा 380. Reaction will be plus ना.
Reaction is acting upward sir. Yes sir. Yes. Okay sir. Thank you. Reaction acting upward.
Okay, good, you did it and you did not get it. It's okay, now it's okay. I brought that question here. Now I want you to read this first question. It says, a box-shaped vessel 40 meter long has a light displacement of 320 tons. So this is the box-shaped vessel. Length 40 meters, breadth not given, light displacement 320 tons. Is divided into 4 holes of equal length. So each hole is 10 meters. Let's say 1, 2, 3, 4. Hold 1 and 4 are loaded with 200 tons of cargo, trimmed level. So that means cargo here is 200 tons. Likewise, cargo here is 200 tons. And number 3 and 4 holds are loaded with 400 tons each. Draw the SFBM diagram of this vessel. Now, first and foremost, if the light weight of the ship is given, if you say light weight of a ship is not uniformly distributed along the length, you are absolutely right. Why? Because somewhere you will have the windlass, somewhere you will have the cargo gear, somewhere you'll have the pump room, somewhere you'll have the machinery space. Weights will be concentrated in different portions. Okay. But to be able to use a specific case, there has to be information provided. So Under these circumstances, with the question on display where there is no detailing given about the light displacement except for the value, we will be compelled to assume that light displacement is uniformly distributed. Am I clear, beta? Even if it is not said, because otherwise you'll have to give me details. Where is the machinery? What is the weight of the machinery? Where is what? And what is the weight of each component, right? If it is not given, even though it is not given in the question, we will assume that in that case, that the light weight is uniformly distributed. Light displacement is uniformly distributed. Is that clear, beta? Guys, am I clear about the assumption we have made here and for the reasons the assumption had to be made? Is that clear to everybody? Bolo bhai?
Yes, sir.
So we will assume that light displacement is uniformly distributed, so it becomes 8 tons per meter. Okay. Now, this vessel will float. Look at the weight distribution. Light displacement is uniformly distributed. About midships, the cargo weights are uniform about midships. And it's a box-shaped vessel. Do you think this vessel will float on even keel or will it float with a trim? Will it float on even keel or float on with a trim?
Even
Even
keel,
keel,
sir,
sir.
box shape.
Okay, very good. What is keeping the vessel afloat? Why the vessel is not sinking?
Buoyancy,
Because of the buoyancy. Yes or no?
Buoyancy.
What will be buoyancy equal to? The total displacement. Displacement is what? Cargo weight plus light displacement. If you add them all, it comes to 15-20 tons. So this much is the buoyancy, correct? And since it is a one box shaped, two floating on even keel, because of these two reasons, the buoyancy is uniformly distributed. Why? Because what is buoyancy? It is the weight of the water displaced. So if it's a box-shaped vessel and you cut it into lengths of say 10 meter each section from forward to aft will displace the same volume because it's box-shaped, cross-sectional area will be same, and the length is same, so the volume displaced will be same. So each portion is exerting the same buoyancy. So we can say the buoyancy is also uniformly distributed. Why? Because it's box shaped and even keel. Now compare this question to the question of beam, which is there pasted in the inset here. There the beam was of uniform cross section. That means the weight of the beam was uniformly distributed. Here we are saying it's a box shaped vessel, light displacement 320 tons. And for the reasons I explained to you, we have assumed that the light displacement is uniformly distributed. So can this ship be treated like that beam of 40-meter long, 320 tons weight? Yes or no? Uniform cross section. Can this ship be treated like that beam? Yes or no?
Yes, sir.
Okay. Then the weight, the cargo in number 1 and number 4 hold. Don't you think it is like UDL of 200 tons on 10 meters each on the beam? Yes or no? And the cargo in number 3 and 4 hold, 2 and 3 is like 400 tons of UDL, total 800 tons over that length. So do you agree with me that the cargo in this box-shaped vessel is exactly like the UDL on that beam? Yes or no? Correct? Correct, beta? Guys, do you agree that the cargo in the box-shaped vessel is like the uniformly distributed loads in on that beam? Yes or no?
Yes, sir.
And there the beam was completely resting on the ground, so the reaction was uniformly distributed, which was equal to 15-20 tons. Here, the downward weight is balanced by buoyancy, which is uniformly distributed. So buoyancy replaces the reaction here. So don't you think that if I consider this box-shaped vessel as a beam, and let me draw the beam on the box-shaped vessel, overlay on the box-shaped vessel with a green line. If I treat this box-shaped vessel as a beam, now you see this is the beam, I have treated it as a beam. This green line is the light displacement. Then these are the UDLs on this, and it is being supported by the buoyancy from beneath. Yes or no, uniformly? So do you think this box-shaped vessel, if it was to be represented like a beam, then it can be represented by this beam? Yes or no? Can this box-shaped vessel be represented by this beam? Tell me, guys. All the forces are exactly identical in the two cases. Yes or no? Please review and tell me, can this box-shaped vessel, which we have assumed, be represented by this beam that we just solved? Yes or no? Yes or no?
Yes, sir.
So, if it can be represented by that beam, and the beam SF diagram was this, and BM diagram was this, what does it mean? It means that for my vessel also, then the SF diagram will be the same as that for the beam. So for this box-shaped vessel, this will be the SF diagram, and this will be the BM diagram for the box-shaped vessel. Yes or no? If they are same, both beam and, as far as the forces are concerned, the beam and the box-shaped vessel are identical, then their shearing force and bending moment diagrams will also be same. Yes or no? Please confirm if you are in agreement. Correct?
Yes.
So guys, every ship, not only box-shaped, every vessel can be represented as a beam, okay, and can be solved as a beam. However, in every ship, be it box-shaped or ship-shaped, everything may not be so conveniently distributed as we have taken in this case. Here, in our simple example, the box-shaped vessel converted into a very simple beam, and the beam could be easily solved. Every time the ship may not convert into a simple beam. So please understand what I'm saying. Every vessel can be converted into a beam problem. Whether it gets converted into a simple beam problem or a complex beam problem, that's notwithstanding that, but every ship can be converted into a beam problem. Now, if every ship can be converted into beam problem, but it's going to convert into complex situation, then that is not a user-friendly way. So in dealing with the ship shape or the box-shaped vessel, whatever you want to say, yes, they can be converted into beam. And if I'm on top of my mathematics, if I'm good in mathematics, and if I know my concepts, any complex beam can be solved. Whether regular, irregular, varying, not varying, any beam can be solved for SA beam, guys. So you cannot say beam cannot be solved. I'm not saying that. But every time solving a complex beam may not be the best option for me. So what is done is, when we deal with the ships, we avoid going via the beam route. We avoid going via the beam route. I'm not saying we can't go via the beam route. And we introduce one more curve before the SF curve. Until now, what have we done? We know that we get the SF diagram, and SF diagram leads us to BM diagram. This is what we already know. What we will do now is, we will not calculate the SF the way we calculated for this beam here. We will make one more curve before the beam. So the SF will precede another curve called as the load curve. So what, in case of ships, be it box shape or ship shape, We will first make a load curve. Then from the load curve, we'll make the SF curve. And from SF curve, you know how to get the BM. This part you already know. So this known to all of you. This is not an issue. How do we get from load curve to SF diagram? Exactly the same way, by integrating areas under the load diagram. Same concept as you used from SF to BM. Exactly the same. No change at all. So what we'll do is, for this box-shaped vessel, we'll use this concept to get the shearing force diagram. If we get the shearing force diagram correctly, that means you will be validating the process, and thereafter we'll start using the route, not via the beam route, but via the load curve route. Guys, any question on what I said? If you want to ask anything, if you missed out anything that I said, or you have not understood what I'm trying to say. Okay. So now, what I'll do now is I'll introduce how to get the load curve, complete this question via that route, so that you are able to complete such simple questions, which often come in exams also. So that tomorrow we build on that, and then tomorrow I'll be safely, conveniently be able to close out your SLBM, no issues at all. Okay, guys. In these cases, now please pay attention and you can interject anytime. First, we'll make the box-shaped vessel diagram, as it may have been given to us in the question. So length 40 meters, breadth not given. If it was given, we'll put on it. Divided into 4 holes, 200 tons. And since it's trimmed level, it will be at 20 tons per meter. 400 tons. Since it's trimmed level, it will be 40 tons per meter. 400 tons. Since it's trimmed level, it will be 40 tons per meter. 200 tons. Since it's trimmed level, it will be 20 tons per meter. Light displacement 320 tons, and we have assumed it to be uniformly distributed, so it shall be 8 tons per meter. This will result into a total buoyancy of 1520 tons. And since the distribution of the weights is symmetrical about the midships, we will basically, you can make the water line wherever you want. The vessel will be floating on an even keel draft. Buoyancy will be equal to 1520 tons, distributed at a rate of 38 tons per meter. This is the diagram I have made. Guys, if you have any questions, let me know. I am not interested in the draft because I don't know the breadth, so I'll not get the draft. Why the buoyancy is uniformly distributed? Because of 2 reasons. A, it's box shape together with uneven keel. If any of these 2 conditions is not fulfilled, then buoyancy shall not be uniformly distributed. Guys, is the diagram clear? I'll move on once the diagram is clear to everybody. Once you confirm that the diagram is okay and you have understood what I said. Everybody is got the diagram right, beta? Understood what I said in context with the diagram?
Yes, sir.
Okay. Now we will identify the key points for the load diagram. Okay. And usually we take all the bulkhead locations. That's why in the last question also I marked C. I did not use it. In this also we could avoid using C, but since bulkheads are marked, we'll take it there. Okay. So we had in the last question in the beam, we had marked it like this. If you remember, A, B, C, D, E. Now at these 5 points, we'll calculate the load. Now you'll have to now understand how we are making the load table, guys. We will decide for how many points the load table is to be made. And looking at the diagram, we saw that there were changes taking place at practically every bulkhead except C. and C we included because there was a bulkhead, otherwise there was no reason to include. And then we decided we'll make a table for 5 points. So 1, 2, 3. Okay, so we can make little wider. 1, 2, 3, 4, and 5. Okay. Points are A, B, C, D, E from left to right. Now here, first we will see what are the downward weights. Guys, in this question, please speak up and tell me what are the weights acting downwards in this question. Name the weights, not the values. Name the weights which are acting downwards.
Light ship and the weight of the cargo.
Light ship and the weight of the cargo. So we'll first take stock of them. Now, first we will take the light displacement. And in which units? Tons per meter. How much is the light displacement per unit length? Okay. Now for light displacement, we will divide the first and the last point into two parts. Why? Because to the left of A, there is no light displacement, there is no ship, so there is no question of light displacement. The moment I reach right of A, that means at A, the change is taking place from 0 to 8. Why? Because the moment I go to the right of A, just to the right of A, it becomes 8 tons per meter. So that means 0 to 8 change in the light displacement is taking place at A. At B, the light displacement is 8 tons per meter. At C, it is 8 tons per meter. At D, it is 8 tons per meter. Just to the left of E, it is 8 tons per meter. Just to the right of E, it becomes 0. Guys, any question on the first row that we have filled up? Light displacement in tons per meter. Is that clear, beta? Is that clear, beta?
Yes, sir.
Okay. Next, we'll deal with the second downward force, that is the cargo weight. How much tons per meter? Now look at the diagram. I will decide whether the cargo weight at each point is changed per unit length, changing on either side. Is the cargo weight on either side of A, left of A or right, and right of A different or same? Left of A and
Different,
right
sir.
of A, is it same? To the left of A and right of A, cargo weight?
Different, sir. Different.
Different. So that means A, I'll have to divide. Likewise, now have a look at B, C, D, and E, and tell me which all cells need to be divided into two, where it is changing on the two
All
sides.
the cells, sir.
On
No. B needs to be divided and D and E.
Okay, C need not be divided because to the left of C and right of C, it is the same. Yes or no? That's what you're saying. Correct, guys?
Correct, sir.
Okay. Now, please speak up. What is the weight per unit length to the left of A? I'm sure you'll agree 0. Look at the diagram. What is the weight per unit length to the right of A? Value?
20.
20.
20.
To the left of B? 20. To the right of B? 40.
40.
At C? 40. To the left of D? 40. 20. 20. 0. Does everybody agree with the weights I filled in? Right, guys?
Yes, sir.
Okay. Is there any other weight acting downwards other than these two? No. So this gives us the total downward weight or total weight. In which units? Tons per meter. Now between the light displacement and cargo, whichever cells are divided into two, you will divide them two here also. And in this third row, you will write the sum of the above two. Left of a point will be added to left of a point. If it is not divided, it will be added to both. Okay, so it is 0 plus 0, 0, 20 plus 8, 28, then 28, 48. This 8 will be added to both. Then 48, 48, 28, 28, and 0. I have added this third row, the red one, is sum of the above two rows. Is that clear? Because they constitute the downward forces. Yes or no? Correct? Correct, Bete?
Yes,
Please
sir.
have a good
Yes,
look
sir.
at it and let me know if there is any clarification required. Okay.
Sir,
Now,
please explain this C part, sir. 40, 40. Both side is 40, no, 40, 40.
yeah, so then there's no point in dividing, no, when it is same on both sides. Yes or no, beta?
Okay, okay.
Okay. If it is same, if the division is meaningful only if it is changing. Now, if it is not changing, then whether you divide or don't divide doesn't matter, right? Yes or
Yes,
no?
sir. Yes, yes, sir.
Okay. Now, this total weight is acting downwards. We are going to work in our figure from left to right. We have agreed earlier in the first lecture. And from left to right, downward forces are negative or positive, guys? From left to right in our beam questions, were the downward forces negative or positive?
Negative.
Negative.
So
Negative.
we'll put a minus sign here against all of them. Okay. That completes my downward forces. Now look at the box-shaped vessel diagram. How many forces are acting upwards?
Only one buoyancy.
Buoyancy. So we make a column for a row for buoyancy in tons per meter. See if the buoyancy at any point to the left and right is different, then we need to divide those points. Tell me, are there any points where the buoyancy is different to the left of that point and right of that point?
At
A
A and E.
A and
A and E,
A
very
and
good.
D.
Where A and E, right. Buoyancy here will be 0 since there is no ship, no displacement of water. Then it becomes 38, 38, 38, 38, 38, and 0. Buoyancy is acting upwards, guys. And when we go from left to right, upward forces we have taken as positive. So I put a positive sign here. Don't say missing sign is positive, sir. You need to put the sign. Okay. If it is plus, put plus. If it is minus, it put minus. Don't say that it can be assumed to be there because I did not put a sign. Now we come to a row, which is the last part of this column. That is the load. So what is load actually? Load is not something which is acting downwards in this context. Load is the resultant of downward and upward forces per unit length acting at each point. Load is the resultant of, so what is the load a thing is facing? The load it will face is how much is the downward force and how much is the support. The resultant is the load at each point. So the load in this context is the resultant of downward and upward forces. Now, for this, we will only use the blue and the red row because the red row already takes care of the two green ones on top. And we will divide all the cells which are divided either for that weight or in the buoyancy row. And if we look at these two rows, we need to divide these two and these two. And now we find our resultant. 0, 0 gives you 0. Plus 38 minus 28 gives you plus 10. Plus 38 minus 28 gives you plus 10. Plus 38 minus 48 gives you minus 10. You get minus 10 here. you get minus 10 here, you get plus 10 here, you get plus 10 here, you get 0 here. Please have a good look at the load in tons per meter. Please remember in the first column, everywhere I have put the units. I have put the units in every cell in the first column is tons per meter, tons per meter, tons per meter. Have a good look at it. Your load table is completed. Your load table is completed. Is the making of load table up to this point clear, bete? I'll just take 10 minutes or so more. Please bear with me so that I can complete and you can use your day better. 10 to 15 minutes, not more than that. Is the load table clear, beta?
Yes, sir.
Yes, sir.
Okay, now we will make the load diagram based on these values. Load diagram. I have minus 10 and plus 10, so I don't have to worry about the scale. And you should also learn these tricks. Whatever you take as plus 10, same distance you can take minus 10. This will be load in tons per meter. I have A, then 10 meters from here I have B. Then I have C, I have D, I have E. Now, at A, the load changes from 0 to plus 10. Look at the table, bete. At A, the load changes from 0 to plus 10. Then from plus 10 to B, it remains plus 10. So this is plus 10. At B, it goes to minus 10. Then it remains minus 10 to C, continues to be minus 10 up to D. Then it goes to plus 10 and becomes 0. Please see if you're comfortable with the load diagram. If you're not, let me know. This has come from, so this last values here, they are taking us to this diagram. Bete.
Okay.
Okay. Now we will use this load diagram. Now my focus is not on the box shift vessel. The job of the box shift vessel is done. Now my focus shifts to load diagram. Guys, what was the criteria for choosing the points from SF diagram for the BM table? What was the criteria? Would somebody like to quickly repeat the criteria? From SF to BM, SF diagram to BM points, BM table points, what was the criteria?
All the points in SF table and where this
And
zero.
additionally, where it cuts the x-axis. Same is the criteria for points for SF table from the from the load diagram. Look at the load diagram. Whatever points you've taken the load, all those points, you will, whatever points you've taken the load, at those points, you will basically be taking the SF. Okay. So now we will make the SF table, and now we will write here by SF table by areas under load diagram. Under load diagram. And there is no extra point where it is cutting the x-axis. So now I will basically be taking at 5 points only, 2, 3, 4, 5. Now there is no need of any splitting. Why? Because whether you have to divide a cell into 2 or not, it happens only in the first table. In the beam case, we were making the SF table as the first table. So the question came whether the cell should be divided or not. Here, load table is the first table, so we thought which cells to be divided. Once you start using the area, then there will be no sudden change. So there will be no cells divided now. SF will be in which units? You see, it is ton meter on the y-axis load. Length of the beam is in meters, so it will be in tons. The way you are using the SF for BM, use the load diagram. Tell me guys, what is the SF from the load diagram? Is there any area under the load diagram left of A? Yes or no?
0.
0. I carry forward 0. What is the change in the area? What is the change in the area from A to B? With sign.
100.
100.
Nahin, plus 10 into 10, right? Plus also beta. So the SF will be plus 100. I carry forward plus 100. What is the change from B to C in the area? Minus 10 into 10 becomes 0. I carry forward 0. What is the change from C to D? Minus 10 into 10 minus 100. I carry forward this minus 100. What is the change from D to E? Plus 10 into 10 becoming 0. Yes or no? Yes or no, beta? Correct?
Yes,
Correct,
sir.
sir.
And if you refer to that beam question, your SF at A was 0, at B was plus 100, at C was 0. You can see here. It was 0, plus 100, 0, minus 100, 0. And same SF you've got here in the table through this route. Yes or no? Have you understood, beta, what have I done here? I'm keeping it. I can take you back if there is any need. Okay. Now, we will make the SF diagram now, and the SF diagram will have its shape drawn from load diagram. SF diagram will have the shape drawn from the load diagram. So now we make SF diagram from these values from this table. A, B, C, D, and E. SF will be in tons. It is plus 100 to minus 100. Now look at the, let me put the values first and then I'll ask you the questions. SF at A is 0. SF at B is plus 100. Guys, look at the load diagram from A to B. Is the area changing at a uniform rate from A to B? Yes or no? Load diagram is here. Here is the load diagram on the smaller version.
Yes.
A to B, is the load changing at a uniform rate? Yes or no?
Yes.
If yes, it will be straight line. If no, it will be a curve. Tell me fast whether it is changing at a uniform rate from A to B, yes or no?
Yes, sir.
So it's
Yes, sir.
just a straight line. Then at C, it is 0. Look at the diagram. From B to C, is it changing at a uniform rate? Yes, straight line. C to D, D is minus 100, changing at a uniform rate. So straight, all these three are in a straight line. And likewise, D to E, 0. This becomes the SF diagram. Yes or no, beta? Correct? Plus 100, minus 100. Now we'll make the BM table. Let's close it out now. BM table. Do we need any other point than these 5? No. Had I taken 4, then C would have been required to be included. But since C is already there, so no need to take any more point. A, B, C, D, E. This part you know, I don't have to explain anything here. Ton meter. A, 0. Carry forward 0. Up to B is plus half into each section is 10 meters here. Half 10 into 100, that is plus 500. Plus 500, another half into 10 into 100, plus 1000. plus 1000 minus 500, this half triangle will be plus 500. Plus 500 minus 500, 0. Does everybody agree with the BM table? Yes or no? If anybody hasn't, this you already know, beta. In beam questions, you have done BM from SF, yes or no?
Yes, sir.
And now our
sir.
focus is on SF diagram. Now load diagram is also done. Now our focus is on SF diagram. It's A, B, C, D, E. BM in tons, plus 500 and plus 1000. At A, it is 0. At B, it is plus 500. At C, it is plus 1000. At D, it is plus 500 and 0. Look at the SF diagram. From A to B, is the triangle vertex to base or base to vertex?
Vertex to base.
And the next one, B to C?
Base to vertex.
So beta, it is base, vertex to base, then becoming 0 here because the vertex is at C, and replica of this.
Yes, sir. Mirror image.
Mirror image of this. This becomes the BM diagram for this box-shaped vessel. So these are the SFBM diagrams for this box-shaped vessel through the load curve, through the load curve. So we will not be using the beam concept for box-shaped vessels. We'll be going via the load curve. Why? Because that will be simpler to handle than going via the beam concept. Guys, have you understood the addition of the load curve? That's the only change. Rest everything is a repeat of beam. There is nothing new from SF to BM. Tell me now if you have any questions. This is what I wanted to achieve today, actually. Fortunately, I've been able to achieve. So this is because with this, you'll be able to do at least 3-4 questions from past papers. Which questions basically where the vessel ends up even keel and weights are trimmed level, uniformly distributed. And there are questions many a times on this. So it's not that questions are not being asked. If you want, you can take the screenshot. If you have missed out any page, let me know if you want to take any screenshot from this discussion of today on box-shaped vessel beta. If it is okay, then I would like to close out. If you have any questions, I'll be happy to answer, guys. I'll be sending you the questions right away. And I'll also maybe mark on those questions with a tick or something, which you can do now based on the discussion that we have had. Then tomorrow we'll be in a position to close out the SFBM. And then, of course, we'll be having some small miscellaneous topics that we'll be covering, standalone topics, which will not spill over to the next day. They'll be closed that very day in the class. Guys, any questions or shall I close the meeting then, beta?
Yes, sir. Please, you can close. Please send the question.
Okay, sir.
Okay, guys. So we have
Thank you,
learned
sir.
how to deal with the box-shaped vessel, a simple
Thank you,
scenarios,
sir.
but a lot of. Okay, guys. See you then tomorrow. Bye, beta. Thanks.
Thank you, sir.
Bye, Vicha. Bye.
Thank you, sir.
Bye, guys. Bye. Okay.